Hello and welcome to my video. Today we are going to find the minimum distance between the fixed point 0, a and the parabola y equals 1 over 16 x squared, where a is constant. So this y equals 1 over 16 x squared is the parabola that is convex and has point 0, 0 as its vertex, and 0, a is a point on the y-axis. Okay, now let x, y be the arbitrary point on the parabola y equals 1 over 16x squared, and let d be the distance between 0, a and x, y. Then, if you use the formula for distance between 2 points, d squared equals x squared plus y minus a squared. Okay, now since x, y is on parabola y equals 1 over 16 x squared, we have this relation. Now some of you might want to use this relation to eliminate y and thus obtain d squared as a function of only x. However, if we do that, we obtain a quartic expression of x, which means d squared is given as something like this with x to the power of 4, which is actually not that difficult to deal with in this particular problem, but can become quite complicated occasionally. Therefore, in order to maintain the degree of the polynomial as low as possible, we instead use x squared equals 16y and use this to eliminate x squared right here, so we can express d squared with only one variable y. Then we have d squared equals 16y plus y minus a squared. And if we expand this, we have, as you can see, d squared is a quadratic function of y, and in order to find its minimum value easily, we transform into the vertex form. So we write y squared minus 2a minus 8y plus a squared. And in order to complete the square with this part, we simply add a minus 8 squared and subtract a minus 8 squared plus a squared. So now this part is a complete square. We have y minus a minus 8 squared, and the remaining part is a minus 8 squared plus a squared, which finally gives y minus a minus 8 squared, and if we expand here, we have 16a minus 64. And now the quotient. Some of you might want to say that from this vertex expression, d squared is minimum when y equals a minus 8, and the minimum value of d squared is 16a minus 64. But that is not always true, because you see this point x, y is on the parabola y equals 1 over 16x squared. So the possible range for y is equal to or greater than 0. Therefore, this y can have a value of a minus 8 only if a minus 8 is non-negative. Otherwise, when a minus 8 is indeed negative, the value of d squared cannot have this value, because this value is obtained when y is negative. So let us treat these two cases separately. So if a is equal to or greater than 8, then d squared is minimum when y is equal to a minus 8, this value, and the minimum value is this. And for the second case, when a is less than 8, then this a minus 8 is negative, so y cannot have that value. Here, let's examine this d squared with respect to y. So d squared is a quadratic function, and the vertex is at a minus 8. And the second case is where a minus 8 is negative, and this y value is defined when y is non-negative. So the possible value for d squared is only this part, which means that in this case, d squared is minimum at here at y equals 0. So it is minimum when y equals 0, and its minimum value is, or you can easily find out that the minimum value of this square is simply a square. Right, so if we write down our answers for the value of d, the minimum value of d is given as 4 times square root a minus 4 when a is equal to or greater than 8, and simply the absolute value of a when a is less than 8. Now this means is that let this point be 0, 8. So the first case means that when 0, a is up here, then the minimum distance between this point and the parabola is the distance between 0, a and some point on the parabola, here and here. So d is minimum here. And what this second case means is that when a is here, then the minimum occurs at y equals 0, which means the distance is now between 0, a and the origin. So this is the minimum distance. And the same argument also holds when a is negative, or in this case, obviously, this is the minimum distance. Alright, so that was all for today's video. Hope you found this video useful. If you want more math videos, please check out my channel, and I will see you in another video.